So anyway, this is Glenn back with another video, Glenn in the Fields, and in today's video we have a geological strata here. Oh, beautiful. You just want to go and lick it. Awesome. So what we have here is we have layering in the actual rocks. As you can see, the different layers, and if you don't know the principle of horizontality, this is actually a good place to actually learn it in one of these layers. So basically what it says is that the layers that are actually down the bottom are oldest, and the ones that are up the top are youngest for rock that has not been deformed. So this rock actually has been deformed. So this one looks like it has a dip, probably of about like that. So I would say probably at least 45-degree dip. So the actual dip is actually going into the rock. So, and going into the ground. And so if we go this way, you're actually forming a anticline, and then there's a syncline. Basically that's what is actually my interpretation of this area. So within the actual rock you can see there is one layer here, and there's another layer. You can see different layers in the actual rock. So this probably forms another layer. So obviously this is probably siltstone, probably a lot of irons, because this is actually quite strong. It's very hard to actually break this type of rock. This one is actually, you can actually, so if you do that, you can actually scratch it with your hands. So this is actually very soft. And you've got very hard inclusions, probably iron inclusions as I said before. And then we actually have these dark, probably silt. So, and these are actually quite strong. So they might actually be previous or rocks from, I don't know, a river or something. They're actually not very common. So there's two there. There's another one over here. So they're actually very hard. Oh, you can actually break it. Here we go. It looks like it's probably just siltstone. It's probably, I don't think it's actually formed in this rock. It's probably come as a cobble boulder, and it's been included, a bit like how a conglomerate or breccia would actually form. So I don't see any others pretty much. So if we actually have a look at the actual rock itself, you can see this is eroded, a lot more laminations. And up here we actually have quite a thick formation. So this is actually quite strong. And this rock here, generally, it doesn't actually have any fossils in it. So you're not going to find any fossils in a Dargol formation. Okay, so here we are. So as you can see, lots of layerings. This looks like a sandstone in itself. So basically what you've got is you've got siltstone here, you've got a sandstone, and you got more siltstone at the top, more sandstone, and up the top you actually got pretty eroded rock. So basically that is what is in the Dargol formation. And this is actually Silurian, so it's actually probably about, oh, so here we go. Here we actually have it. We have a Dargol formation, sandstone laminated current beds with interbedded siltstone, shales, hornfels in metamorphic orioles near Quarry Hills. So the hornfels is the actual rock type. Metamorphic means it's been altered by the Devonian granodiorite, and that's actually over in that direction. That is basically the sedimentary rock of this area. Got layerings of sediments, pretty much the youngest is down the bottom, the oldest is up the top. But because there's no fossils in it, we can't actually test that hypothesis. This could be overturned, and if we go over that way, we'll actually see a syncline and anticline. Okay, so around here, this is the best formation of an anticline, so it actually goes up like a hill. If you want to go syncline, the syncline sinks, so it actually goes down. So if you turn it upside down, it would actually be a syncline. And you can actually see that there's another anticline up there. I don't see any syncline exposures, but based on this rock here, which actually has a dip of probably about 180, so this one probably forms a pretty tight syncline, so probably something like that. So if you put my thumb there and the actual rock there, so that's actually the syncline. That's actually a tight turn, so it's probably even fractured and it's been pushed together, so there might actually be a fracture there. So this is actually the deformation of the actual rock. So as the land has actually risen up, so it's actually collided with another continent. This has been squashed to the other continent. All the rock's been squashed together, and because it's got nowhere to go, it actually goes up, and it actually gets deformed in the actual process. So this deformation is pretty much deep, so probably 5 kilometers or so deep, and it's actually pretty eroded. So here we actually have the ground level, so up there. So this has probably been eroded since the Devonian, so at least 350 million years this has actually been eroded. And if we go over that way, on that side, that's actually basalt, so all that has been covered in basalt. And oh, it's such a beautiful day. So there's the sun. Yeah, so that is all basalt over there. And then on this side of the river, so we've got that side, and this side of the river is all the actual sandstone. So yeah, and over there it's all deformed as well. It's all deformed, but behind me it's actually not too deformed, so it actually doesn't show that much deformation behind me. So it depends on what area you actually go to. And